Hi students, today we are here to take the second PUC in 12th classes for the matrices. So we'll see that the definitions, the orders, the types, the properties, operations upon the matrices. First I'll define that what is called the matrix. In your common language, in your general term, you can say if it consists the rows and the columns is known as a matrices. Simply we can say that one. But if you want some diplomatic answer or the definitions for the exams, you can say that it is an ordered arrangement or the ordered rectangular array of the functions or the elements. That is your definition of the matrices. Means if it is in the form of the rows and the column is called the matrices. Order it is called m by n. So there will be m and n order. Like if I use this A as a matrices, here if I write 3, 2, 1, 1, 2, 3. So what we call, how many roses are there? M by n is nothing but m is your for rows and the n for the columns. So this is for the columns. So how many columns are there? 1, 2, 3. So this is your 3 columns. How many rows are there? 1, 2. So 2. This is nothing but your horizontal. Horizontal is known as a rows. The column is nothing but the vertical elements. Vertical elements are known as columns. So these two things are there, the rows and the column in the matrices. Now we'll see the types. The column matrix name itself suggests that column matrix is nothing which has the only element in the column. Like if I write here, only the column has there 3, 2, 1. So this is called as a column matrix. Rows, similarly for that rows, only the rows element are there. This is known as a rows matrix. Square matrix, which has the equal number of the rows and the columns. If I 3 by 3 matrix if I take, it is known as a square matrix. So now it is a diagonal matrix. Diagonal matrix is nothing but which has the diagonal elements only, and other than the diagonal it is a 0 only. Like if I take the diagonal matrix, is only the diagonal will be their element, no other element will be present there. Let it be I am taking 2 here. The other will be the 0 other than the diagonal. So this is your diagonal matrix, means only the diagonal elements will be present there. Other than the diagonal elements, non-diagonal elements will be 0. So you can see that one, other elements are the 0. Next it is coming the scalar. Scalar is the same like a diagonal matrix, only the one thing is there. The other elements will be 0 except the diagonal, but the diagonal elements will be same. Means it should be the equal. Scalar matrix is nothing but only the diagonal elements are same. That is only the diagonal matrix is there. The only difference is the diagonal elements must be the equal. If I am taking as this 2, so other element will be 0, but the diagonal element must be equal. So 0, 0, 2. It can be here in the scalar matrix root 3 also, the 5 also, anything can, but the diagonal elements must be equal. So diagonal एलिमेंट जो होता है वो इक्वल होना चाहिए, बाकी सारे एलिमेंट जो होते हैं वो 0 होना चाहिए. तो ये एक तरह से आपका डायगोनल मैट्रिक्स हुआ. बट डायगोनल मैट्रिक्स में क्या था, कुछ भी एलिमेंट्स हो सकता है डायगोनल में, इक्वल होना जरूरी नहीं है. बट द स्केलर में क्या होता है कि स्केलर में इक्वल होना चाहिए, डायगोनल एलिमेंट्स जो होता है वो इक्वल होना चाहिए. अपार्ट फ्रॉम दैट द अदर नंबर विल बी 0 ओनली, अदर एलिमेंट्स विल बी 0 ओनली. नाउ वी हैव दैट identity matrix. Identity matrix has its own changes in the scalar matrix. So identity matrix means all the elements will be the diagonal elements will be the 1. Like if I take, I'm taking here as a 1, 0, 0, 0, 1, 0, 0, 0, 1. So if the diagonal element is 1, is known as a identity matrix. So identity matrix में क्या हो जाएगा, जो diagonal का element होना चाहिए वो 1 होना चाहिए. Apart from that, the other elements, other non-diagonal elements must be 0. Now we have the 0 matrix. 0 matrix, all the elements will be 0. Then it's called the 0 matrix. If I take the 0 matrix here, so all the elements will be 0, 0. This is known as a 0. Sometimes known as a O also, or the 0 you can say. It's a 0 matrix. What is your equal matrix? Which equal matrix has the same order. Means m by n must be equal, like 3 by 3, and two conditions are there. One condition is that the order must be same. Second is that corresponding elements must be equal. Then it is known as a equal matrix. If I take here A and the B, two matrix if I take, and all the elements, corresponding elements are equal, then we known as a equal matrix. Like A if I take as a 1, 2, 3, 4 here, another if it is coming as a B matrix also it is coming as a letter B 1, 2, 3, 4 only. Then we can call as A is equal to B. So both matrices are equal. So this is known as a equal matrices A and B. Hopefully this is the types of that the matrices. Next is coming operation. Operation is the same only, like addition, subtraction is the same only. The corresponding the elements will be added and subtracted. Only the multiplication is different, that we'll see later on. Now the properties is also same only, associative property, commutative property, or closure properties, or the inverse properties, all are same only as we do in the real numbers. So most of the properties are the same as we do in the real number in the matrices. Now we'll see that how to construct a matrix. So like if they are given, you construct a matrix A which is a 3 by 4. So then the rows is 3 and the column is 4. So let they have given as a condition Aij as a 2i minus j. This is they have given as a condition here, and now you have to form the 3 by 4 matrix. Means you can take the 1, 2, 3 as a rows, and the 1, 2, 3, 4 as a column you can take. So here we can start like 1, 1 in first row, first column. So in place of the 2 into 1 minus 1. So how much it will come? 1. So I'll do directly as a 1, 2 if you keep, as a 2 minus 2 is nothing but a 0. Next, up to what you can go? 4. The column is how much? 4. So 1, 3 and the 1, 4. We can find it. 1, 3 is nothing but the 2 minus 3 is a minus 1. So I'll write directly here only. So 2 minus 4 is a minus 2. So you got it as a first row. Entire is the first row. First column, second column, third column, and fourth column it is there. Now we'll find that. So using this we will form the matrices. Let I just name as the matrices of 1. So first row, first column is a 1. First row, second column is a 0. Next is a minus 1 and the 2. Second row 3, 2, 1, 0. 3, 2, 1, 0. And the third row is nothing but your 5, 4, 3, 2. 5, 4, 3, 2. So this is a way to form the matrices. 3 by 4, any number they have given, their condition they have given, just substitute and you can find the elements for the respective rows and columns. Hopefully you have understood this one. So now we'll see the multiplication, addition, subtraction, everything will be done with the same order matrices. The order must be same. If we are adding the 3 by 2 matrices to the 3 by 2 matrices only, we cannot do with the 3 by 2 matrices with the 3 by 4 matrices. No, we cannot add that one. So hopefully that is easy to understand. The same order matrices you can add and subtract. So now we'll see that how to do the multiplication. Multiplication, it has a little bit the conditions, terms, how you can multiply. So if I take one example A as a 6, 9, 2, 3, any example, and the let B is equal to, if I take, so now you can check it out. What is the order of this one? As a 2 by 2 only. So 2 by 2 matrices, and this is nothing but the 2 by 3 matrices. 3 columns are there. One condition is there. If you finding the A, B is how much? A into B if you are doing. The columns of A must be equal to the rows of B. So if you do A into B, the columns of A must be equal, the number of the columns must be equal to the rows of the B. If you do the B into A, same will be applicable here. If you do the B into A, then the column of B, number of the column of B must be equal to the row of B, A. That must be equal to A. So now we'll check it out here. First we'll find AB. We'll see how to multiply A into B. So A as a 6, 9, 2, 3, we will multiply with the 2, 6, 0, 7, 9, 8. So how to multiply? Multiplication will be done with the rows with the column. So you have to row wise, you have to multiply with the column. Means this element, the first element of the first row get multiplied with the entire element of the first column. So here it will be like, I'll do, so 6 will be multiplied to the 2 plus 9 will multiply to the 7. 9 into 7. So this will give you the first element of the product of the A and B. This is the first element of the first row and the first column. Similarly, you can do for the second column. So it is 6 into 6 plus 9 into 9. For the third, it is 6 into 0 plus 9 into 8. Now the next is coming with the 2. Again, you have to multiply with the entire. So 2 into 2 plus 3 into 7. Next will come the 2 into 6 plus 3 into 9. Right? Next will be 2 into 0 plus 3 into 8. So this will give you the entire or the product matrix. Now if you will add and all those subtractions, so 12 plus 63, here the 36 plus 81, here the 0 plus 72, the 4 plus 21, and the 12 plus 27, and the 0 plus 24. So this will come here what? As a 75. Next will come as a 107. Next is a 72 only. Here 25, 39, and this is a 24. So this is your matrix for the A into B. If you multiply, you will get this one as a A into B. तो ये हमारा हो गया A into B. अब हम चेक कर लेते हैं कि B into A अप्लीकेबल है या नहीं, या आप मल्टीप्लाई कर सकते हैं। तो करेंगे क्या, पहले चेक कर लेते हैं हम लोग। मैंने क्या बोला था, B into A मतलब कॉलम ऑफ B, जितना तो कॉलम होता है B में, वो A के रोज के इक्वल होना चाहिए। So how many columns in the B? If I do with it, the column is how much? 3. So column of B is a 3. Is it equal? We'll check row of the A. So A is how many rows? 2. So that is not equal. So if column B is not equal to the row number of the row A, then B into A is not possible or doesn't exist. Is not possible only. One more thing, if you multiply with some scalar number, like the multiply with the 3 with this, the A, the 3A means you have to multiply 3 with all the elements. So like if I will take it here as a 3A. So 3A means what? I have to multiply with the 3 with all the numbers. Whatever the numbers are there, we have to multiply with the 3. So scalar multiplication will be easier, like multiply to entire whole matrices, all the elements in the matrix present, you have to multiply. So here I have taken few examples, so I will just solve this one, and so hopefully you can understand better. The first, they have given find the X matrix, if the Y matrix they have given is this one, and the 2X plus Y is equal to this. So I will just solve this equation first of all. 2X plus Y, they have given as a 1, 0, minus 3 and the 2. So I will just transfer this Y to this side, so it will become the 2X and this 1, 0, minus 3 and 2 minus Y. Y matrix is how much? 3, 2. So I will write 3, 2, 1, 4. So if you subtract 1 minus 3 is a minus 2, 0 minus 2 is a minus 2, minus 3 minus 1 is a minus 4, 2 minus 4 is a minus 2. So this is your 2X matrix. Now if I just transfer 2 to it will just divide that. So X matrix will become minus 2 whole divided by 2, minus 2 by 2, minus 4 by 2 and minus 2 by 2. So after cancelling, what will you get? Minus 1 here, minus 1 here, minus 2 here and the minus 1 here. This is your X matrix. So this is normal addition, subtraction as well as the division. Just it will divide to the each and every elements. Now the next is what? If X into matrix they have given the 2 and 3, the Y into minus 1 and 1 and is equal to some matrix, then find the value of the X and Y. So I'll just check with the second question. So I'll just multiply, so it will become what? 2X and the 3X. This will multiply and become the minus Y and as a Y. So I have is equal to what? 10 and the 5. So I'll add this one, this will become the 2X minus Y and then the 3X plus Y is equal to 10 and the 5. So the corresponding element will be equal, because this is they are saying this is equal matrix, the corresponding elements must be equal. So 2X minus y is equal to 10. The 3x plus y is equal to 5. If you do the elimination method, you get as a 5x is equal to 15. 5 ones are 5 3s are, so x is equal to 3. Keep in this any equation, you will get as a y also. If you put in the 1 only, so 2 into 3 minus y is equal to 10. This y and this will go to 6 minus 10 is equal to y is equal to minus 4. So x and y value is a minus 4 as and 3. So by this way you can find it x and y. Now we'll see the third one. Exam point of view, this is very important question. So a they have given, first we will find the a squared, because the equation they have given a squared minus 5a plus 6i. So a squared is nothing but a into a. So 2 times you have to multiply this matrix. So I'll write, and the last one is what? 1 minus 1 0. Get multiplied with the same only. The 2 0 1 2 1 3 1 minus 1 and the 0. So you know how to multiply. So multiplication will be same only, the rows and the column. So if you multiply, I will just multiply and add it. So 2 is a 4, 0 and 1. So this will become the 5. Next 0, 0 is a minus 1. Next 2 ones are 0 and 0, so is a 2 only. I'll just multiply directly. Hopefully you know that multiplication how to do. So this is your a squared. Now we'll find the 5a. 5a directly will multiply. So I'll just start from the equation only. A squared minus 5a plus 6i. We have to find. So a squared I just got it. 5 minus 1 2 9 minus 2 and 5 0 minus 1 minus 2. थोड़ा छोटा लिखा हूँ क्योंकि जगह यहाँ पे कम है थोड़ा. So directly 5 I will multiply with the a. So minus 5 is nothing but become the 5 2s are 10 0 5 10 5 15. Then the 5 minus 5 and the 0. And I'll write down the identity matrix. 6 into identity matrix means the diagonal elements will be 1. So directly I'll write that. Hopefully you can understand. 6 0 0 0 6 0 0 0 6. So normal addition and subtraction you can do it. Directly also you can do it. Otherwise you can just 5 minus 10. So it will become the minus 5. And plus 6 if you want. Directly if you want you can do it. 5 minus 10 minus 5 minus 1 0 is minus 1. 2 minus 5 is a minus 3, like this. And then you have to add with the 6 0 0 0 6 0 0 0 6. And hopefully you can add this one. So this will become how much? 1. Whether it is visible or not, I'll just write it down here only. So hopefully you can understand. Okay. So 6 and the minus 5 is become the 1. 0 minus 1 is a minus 1 only. 0 plus minus 3 is a minus 3 only. Then the 0 minus 1 6, so it is a minus 1 only. This that is as it is because there is a 0 only. So minus 5 4 and the 6 is become the 4. So this is your answer, final answer for the a square minus 5a plus 6i. So hopefully this entire will help you to how to solve the matrices. So few more points are remaining in the matrices. I'll take in the next class. Hopefully you have understood this basic concept of the matrices. Please like and subscribe our channel to encourage us.